Alright, this is the second video on the notes on 5.7, and what I have is I'm looking at example 1 right here, and I rewrote this a little bit, and up here I wrote the equation for determining the integral for the arc sine, and this initially it's written in du, and I wrote it as integrating. Notice up here I got the derivative of g on top and the square root of a squared my g of x squared on the bottom. And then over here this is supposed to be a g of x. It looks pretty darn ugly. And this is the antiderivative to that. And I want to first talk about how you go through and decide whether you want to use an inverse trig as one of your answers. And I guess what I do is I take a look at this denominator. These are all rational functions because one, they're a function, and then the variable is in the denominator. And if I look at this particular denominator, and I can write it in this form as 4 minus x squared to the 1/2 power. Well, because this exponent is not 1 in the denominator, I can eliminate natural log. I guess I look at 3 parts. I look at, can I do this by reversing the power rule? And by that I mean finding this exponent, adding 1 to that exponent, and then multiplying by its reciprocal. Secondly, I look to see if I can use the natural log, and that's where this exponent in the denominator is 1. And third is I look to use trig inverse, or inverse trig. See if it falls under the one of the first 3 that I listed before. Well, if I look at this, this has an exponent of a negative 1/2, so I would add 1 to this exponent, get a half multiplied by its reciprocal. But what I really need in this numerator right here is the derivative of a negative x squared. I need up here to have a negative 2x, which I don't have. So these 2 steps are eliminated, and so I have to use inverse trig. So what I did is I wrote up here arc sine, and I can see that it matches up with arc sine, because I can rewrite this as the square root of 2 squared minus the x squared. So x, with x in parentheses. And the reason I do that is if I take a look at the derivative of x, is it in the numerator? Well, the derivative of x is 1, and so yes, this is the arc sine, where I can identify a being 2, and that g of x is equal to x. So then my antiderivative is going to be arc sine. For g of x I got a. For a I have 2 plus c. And that's the antiderivative for that particular expression. Alright, let me go on to the next one. And the next one looks like this, and again I'm going to rewrite it a little bit. This is number 2. I'm going to put a 1 up here, and I've got 2 plus 9x squared dx. And what I'm first going to do is I'm going to put this in parentheses, write the exponent of 1. So I'm thinking for natural log. But when I look inside, here's what's inside my parentheses, that if I take this derivative of 2 plus 9x squared, I'm going to get 18x. I don't have that up here. So again, I can't use natural log, and because it's a 1, I can't reverse the power rule. So I'm looking for an inverse trig function to use. Well, if I look at the front, at the ones that I want, the one that I'm looking at looks like this, where I have 1 up here. I don't have a square root, I have a squared, and I'm going to, instead of u, I'm going to write g of x squared d of x, and what this one is arc tangent, which is 1 over a arc tangent of g of x over a plus c. So let's take a look at that. how can I write it so it kind of looks in this form? Well, I'm going to have 1 over, I'm okay with that. And I have the square root of 2 squared, because the square root of 2 squared is 2, plus 3x squared dx. So what I'm saying here is that a is equal to the square root of 2, and g of x is equal to 3x. Now when I take the derivative of g of x, I get 3. So what I need up here is I need a 3, which I can do. I can multiply that by 3. But because I'm multiplying the top by 3, I have to multiply the outside by 1/3. So these simplify, giving me that 1 that I have up there. Now what I'm going to get here is this is going to equal, I wonder if I can get this to disappear. Thank you. That means I'm going to have 1 over what was a, the square root of 2, the arctangent. What's g of x? G of x is 3x over the square root of 2. Now, I can't forget about this times 3, so right here, I need to multiply that times 1/3. Then I have this plus c, and my final answer is 1 over 3 times the square root of 2 times the arctangent of 3x over the square root of 2 plus c. And I don't have to rationalize the denominator, and that's my final answer. All right, let's look at the next one. Excuse me. On the next one, I have this one, which is a little bit more funky. I have x out here in the front, and I have the square root of 4x squared minus 9 dx. Now again, I have, if I look down here, I have 4x squared minus 9, and it's in the 1/2 power in the denominator, so we're going to look at here. So I'm thinking about reversing the power rule, but I would need the derivative up here being 8x, and I don't have that. I have an x out front here, but that's not going to help me if I'm trying to reverse the power rule. So I'm going to look at one of the ones that I have on the front of my notes, and it looks something like this. And if we take a look, over here I have g prime of x over g of x times the square root of g of x squared minus a squared. So if I take a look at that, I could rewrite this as equal to 1 over, here's my x, and over here I'm going to have, instead of 4x squared, I'm going to have 2x squared minus 3 squared dx. So a is going to be 3, g of x is going to be 2x, and g prime of x is going to be 2. Now that means a couple of things. If you notice, right here these two things match up. Well, I have a 2x here and I have an x, so what I need is I need a 2x here, so I'm going to put 2 there. But I also need the derivative of 2x on top, which is 2. Which is fine, because 2 over 2 is 1, and that's this particular denominator right here. So if I continue on with what the definition of this integral is, it's going to be 1 over a, which in this case is 3, times the arcsecant of the absolute value of g of x, and g of x is 2x, so I'm going to have 2x. It's going to be an absolute value divided by a plus c, and that's my antiderivative. All right, let's look at the next one. This is number 4. Now, this will be the last one I do on this video, and then I'll have a third and final video. And this is going to be, I'm going to rewrite this, 1 over the square root of e to the 2x power minus 1 dx. Now this one looks pretty tricky. Again, you can see that if I reverse the power rule, I have a half here, but the derivative of e to the 2x is 2e to the 2x, and that's not what I have up here in the numerator. And so I'm looking at my choices of either arcsine or of arcsecant, and it looks most like arcsecant because I have the function minus the constant. But I don't have this value in here, but I'm going to proceed anyway and see where it takes me. So I'm going to write this as the square root of e to the x, that's squared, minus 1 squared. So I'm saying that g of x is equal to e of the x, and a is equal to 1. Now I'm temporarily going to let e of the x equal u. So e of the x is also going to equal du dx, which means dx can be defined as du divided by e to the x. And so when I substitute in here, here's my 1, here's the square root, I forgot my d to the x there, my square root of u squared minus 1 squared, and I'm going to have du here, but I need to say one more thing. Notice right here that e to the x has also been defined as u. So d to the x is the same as du over u when I replace e to the x with u. So I'm going to put u here. And since this is times, these can be switched around, and I'm going to have 1 over u square root of u squared minus 1 squared du. So u squared, these match up. The derivative of u is 1. So that means I'm going to have 1 over a, which is 1, arcsecant of the absolute value of u over a plus c. So this gives me arcsecant. Well, what's u? U is e to the x. I'm going to have e to the x over 1, which is e to the x. And e to the x is positive, so I don't need the absolute value, plus c. So that is my answer.